Alright, hi everyone. Alright, so what we're going to do today is talk about the syntax and semantics of data log. So what you need to know about data logs: variables start with uppercase letter with underscore, and constants start with a lowercase letter or a digits or a sequence of characters between single quotes. Okay, then we have predicate symbols. The predicate symbols have the same syntax as a constant. And a term is either a variable or a constant. Now, the only difference between what we did before is now we've essentially redefined an atom. So instead of just being of the form P like it was before, you can now have P with some arguments. So P of all of these arguments here, where each of these Ti are terms, which is either a variable or a constant. Alright, so that's the syntax, and the definition of a clause is the same as before. So a clause is either an atomic symbol, which is just a fact, so it's just an atom, or as of the rule A, which is the head of this, which is an atom, if B1 and Bm is true. So these are all atoms, atomic symbols. And a fact, when we're going to define what's happening, is the same as an empty body. So when we give the semantics and saying what's happening, it's going to mean the same thing. It's going to mean empty body. And then we're going to have a query. A knowledge base is just a set of definite clauses. We can just state definite clauses. And the query, I'm going to write here as the form question mark of B1 to Bm. In Prolog, it's written as question mark minus and expects an answer from you. And you're going to put the same format as a body. All right. So now what we're going to do is we're going to define the syntax. So that was the syntax. Now we're going to define the semantics. So the semantics of any language specifies the meaning of the sentence in the language. So we're going to so this one here is going to be a model theoretic semantics. And so what we're going to do is first of all going to do interpretation. So an interpretation is going to specify what objects are in the world. So what we're going to call objects, we're going to call them individuals. Don't think of them like objects as in Java. Think of them like individuals in the chair, like in the world, like people and chairs and tables and airline flights and other things that might be in the world. So these are things in the world. So you want to think about this as objects out in the world. Chairs and trees and courses and programs. Okay. And now we have the interpretation specifies the correspondence between symbols in the computer and objects in the world, relations in the world. So in particular, constants denote individuals. So if you have a constant, it's going to denote a particular individual in the world, and predicate symbols are going to denote relations. So predicate symbols are this symbol inside our computer, and relations are something that's going to be true or false. So here's a formal definition we're going to use. So an interpretation has got three parts to it. First of all, D is the set of individuals. These are the set of things in the world. Okay, they're the set of things in the world. Phi is a mapping that assigns to each constant an element of D. So for each constant, for each constant C, it's going to denote this individual phi of C. So it maps from constants into individuals in the world. Okay. And pi is a mapping that assigns to each predicate symbol, and every predicate symbol has n arguments, so it's a function from d to the n given a tuple of n values into either true or false. So each tuple is either true, or each tuple of n values is either true or false. Right, so here's an example. Let's suppose the constants are these symbols: phone, pencil, telephone. So these are words. This is a word. And suppose the predicate symbols are noisy, which is unary, and left of, which is binary. So noisy is true or false of individuals, and left of is true or false of pairs of individuals. And suppose our domain is this. It's a set of three items. They're not symbolic items. They can be anything in the world. Okay. So now let's suppose that phi of phone is this one, phi of pencil is this one, and phi of telephone is this one. Notice that phi of telephone is the same as phi of phone. And suppose noisy, so that's what phi is. Phi maps these symbols. And so phi of noisy is going to map each entity into each individual into whether it's true or not. Suppose this individual is false, this individual is true, and this individual is false. Now, left of is a is a binary predicate symbol, so it's going to denote a relation of two entities. So for each pair of entities, we're going to say whether it's true or false. Okay, so left of this one and this one is false. Left of the scissors, the scissory thing, and the phone, the old-fashioned phone, is going to be true. Okay, so important to note is D can contain real things, entities, objects, a person, a room, a course, and it can't necessarily be stored in the computer. Pi of P specifies whether the relation denoted by the n-ary predicate symbol is true or false for each tuple of individuals. And note that if a special case, if a predicate symbol has no arguments, then pi of P is either true or false. All right. So now we're going to define what's an interpretation. So a constant C denotes in I the individual phi of C. Okay. This ground atom, P of T1 to the Tn, is true in an interpretation if when we get this pi, if this tuple is in the set of things that's true of pi. Remember, pi of T is a truth value on tuples. It's got to be, when we apply it to this one, it's got to be equal to true. That's what true means. So that's what pi of P is this. And this ground clause is false in interpretation I if H is false and each BI is true, and it's true in otherwise. So this is exactly the same definition we had before. The only thing here is we're going to talk about what entities, what individuals denote, and also what the meaning of when relations are true. Right? And the same definitions we had before. So knowledge base is true in interpretation I if every clause is true in I. A model is of a set of clauses in interpretation in which all clauses are true. And a logical consequence, G is a logical consequence written KB logically implies G if G is true in every model of G. In other words, there's no interpretation in which G is true, no interpretation in which the knowledge base is true and G is false. If the knowledge base is true, G also must be true. All right, so let's look at why we did all that nonsense, all that formal stuff. So what the idea is we're going to choose a task domain, which we're going to call the intended interpretation. And then we're going to associate constants with individuals we want to name. So we're going to give names to things that we want to talk about, entities in the world, things in the world, we're going to give constants to. We're going to assign constants to them. And for each relation, we're going to associate a predicate symbol. And then we're going to tell the system clauses that are true in the intended interpretation. So we're going to write down true facts about the world. Then we're going to ask questions about the intended interpretation. And if this knowledge base, what we told about the world, logically implies G must be true in the intended interpretation because it's true in all models, and by assumptions, our knowledge base contains statements that are true. Okay? It's really important to know the computer doesn't know the intended interpretation, the meaning of symbols. But if people want to understand it, you should convey that intended interpretation in comments for other people and for you in the future. Okay? And when we say, like in the next assignment, give the intended interpretation, it means specifying in comments what objects exist and the mappings of step 2 and 3. All right. The computer's view is the computer doesn't know what the intended interpretation is. They don't know what it is. All it knows is the knowledge base. And the computer can determine, however, if a formula is a logical consequence of the knowledge base. And we know that if the knowledge base entails G, then G must be true in the intended interpretation. If the knowledge base doesn't entail G, then there is a model of the knowledge base in which G is false. And this, as far as the computer is concerned, could be the intended interpretation. So you can't conclude whether it's true or not. All right. So far we didn't do variables. What happens to variables? So variables are what's called universally quantified in the scope of a clause. What does that mean? It means, the way to formalize this is you're going to have a variable assignments, a function from variables into the domain. So just like we had before, this phi mapped constants in the domain, a variable assignment maps variables into the domain. And universal quantification means the clause is true for all variable assignments. No matter how the variable is assigned, the clause is true. Okay? So now, given an interpretation and a variable assignment, each term denotes an individual, and each of the clauses is either true or false. Right, so that's how we're going to define this. So now we can ask this. So now we can have this. We can ask these things. So a query is a way to ask if a particular body is a logical consequence. So we're going to write it as question mark B1 to Bm. So an answer is either an instance of the query that's a logical consequence of the knowledge base, or no, or if prolog sum gives false, if no instance is a logical consequence. So it's going to give you particular instances of the logical consequences. All right? So we'll give lots of examples in class. Thank you.